typically see a blank Geoscience Analyst workspace now. When you open up the application, you should see something fairly similar, a gray or maybe white or black tile in the center, and it's surrounded by a few white or lighter gray colored tiles or panels. We call these panels. That's kind of how we organize the workspace. We'll get into those a bit more quite shortly. But to get started, let's open up something to look at. So what I shared in that in that zip archive should look something like this. We've got a data folder and just a start.goh5 project file. We can open these project files as well as many other file types by just dragging and dropping them right into the workspace. So go ahead and open that start.goh5 by dragging it right into your workspace and then clicking on open and replace workspace when that pops up. That should present you with something awfully similar to this. Let me know if you do see something different. All right. Here in the viewport panel, which is what we have located right at the center of our screen, is a 3D representation of several objects. We've got some blue lines. These are curves. They're essentially polylines, strings, different words for the same kind of thing. They're a line-based representation of multiple nodes connected by line segments. We also have a set of triangulated surfaces. The one shown here is a topography surface, with some colors indicating elevation, and then down below there are some surfaces representing geological contacts and structures. There are also gray lines running through the 3D space here. These are drill holes. The 3D view shows us where these objects are located in space, and it's a spatial lens through which we can view the data sets that are associated with them. We're not really viewing the data directly, but we're viewing data sets plotted on the 3D objects in our 3D viewport. The objects themselves are spatially referenced containers that can hold one or more data sets. So for the first little exercise I have here, and we're starting off pretty slow, just to get everybody up on the same playing field, used to working in 3D. If you haven't used a 3D platform like this before, that's totally okay. We'll have lots of time to cover all the basics. So a few mouse controls just to get used to the look and feel of working in the 3D viewport. You can pan by using your middle mouse button. Click and hold that down and see in the lower left of my screen in the controls panel, the middle click row there is highlighted. That's showing you what I'm doing right now. So keep an eye down there. If you see me doing something like a mouse control and you're not sure what it is, it will show up down there what I'm doing. So I'm clicking on my middle mouse button and I'm just dragging right and left to pan my view back and forth. That's different than rotating the view, which you can do with a left mouse click. So in that case, I'll grab a left click and I can rotate around my 3D objects in the viewport. Pretty simple so far. The key thing about rotating is that we are always rotating around some center of rotation. Right now, mine might be somewhere up in this area. We can change the anchor where our center of rotation is by pressing C and then left clicking on a point or object in our viewport. So I'll press and hold C, and then I can click on, say, this drill hole, and my view gets recentered around that point that I clicked on. Now when I rotate, I'm rotating around a different center of rotation. I like to talk about this one early because that's one like major point of frustration for people who have lots of objects loaded up on their screen, but they're having a hard time viewing or manipulating the view they're looking at them from. It's usually because your center of rotation is not at the best spot for rotating around the objects you're trying to look at. So remember that C left click to change your center of rotation. Look at other areas. Zooming can be done with the mouse wheel out and in just by rolling. You can also zoom by holding down your right click button and dragging in and out, or down to zoom in and up to zoom out. One other thing that's important when trying to orientate ourselves in 3 dimensions is checking the coordinates that we're actually mousing over. So I'll direct your view down to the lower area on the screen. These X, Y, Z coordinates represent where the cursor is floating over an object. It's not sitting on a flat plane at this point. It's actually snapping to whichever object is at the forefront of our view, or closest to our viewing camera. Another way to view those coordinates is by toggling on this XYZ button on the side of the toolbar. So we can toggle that on and see a tooltip come up that will give us XYZ coordinates and also information about our camera viewing angle. So what I'll ask everyone to do is try finding a drill hole. Pick any one drill hole, center your center your rotation on it, and try just rotating around it, zooming in and out, just to get a feel for navigating your camera in the 3D space. And if there are any challenges or something doesn't quite look like it's working in the same way that you see on my screen, shout out and let me know, and we'll take a look at that. Give you just a couple minutes to play around with the navigation.
Yeah, I have one question. So
Sure.
I dropped the starter thing on the platform. I see all the folders on the top left, but there's no box to click and add to the actual screen. So as if there's only empty folders, or like I don't see anything on the center panel.
There's
Which is
nothing.
weird.
Okay,
No.
so you opened up and there's nothing in this center location.
I did it twice. Once I dropped it, and the other time I opened it from my my folder on my computer.
Just by double clicking on it, I guess, from the file explorer.
Yeah.
Okay.
And it did the same.
Did you have that folder extracted already, or is it still inside the zip archive?
It's extracted.
It is extracted?
Yeah.
Okay,
yeah.
Maybe I'll try just dropping another link.
Okay.
Did anybody else see that same problem?
Could try again, but
Yeah, it sounds
take my
like
zip and unzip it again, maybe.
yeah, maybe something could have gone wrong just in the download too. So I wonder. I'll try making another link for it just in case.
Okay.
But yeah, you might try downloading it again. Okay, where did I put? Here it is. But just in case it still doesn't work, or
Okay.
if anyone else has the same problem, I'm gonna make a new file share link and just put it in the chat.
Yeah, I tried it again. It doesn't show anything. Like I see all the folders, but I don't see the Flint Fawn drill.
Yeah,
hole.
you can you
Like,
should be able to expand them by clicking these little arrow buttons, but I'm guessing you're not seeing any of these items inside.
Yeah.
Okay, okay, and there's a problem there too. Is that the same problem for you, Hamza? Oh, perfect. Does anything look different at that link that I sent there, Alexi?
I'm opening it right now.
Okay.
Yeah. Just like the hell? It's exactly the same. Is it with my installation? Or
Sh-
I really don't know what's like. I see the whole thing.
It shouldn't make the install shouldn't have an effect on that. But I wonder, so also in that folder, in that archive, there's a data folder. Could you? Yeah, that's strange. And it's strange that it's just happening on your end.
I don't know. Yeah.
Could you try taking a look in the data folder here? So there was that start, and then there should have been another data folder. And
Okay.
take a quick check in the exercise 9. And there's a
Yeah.
few other things in there too. Try dragging, like, let's just start with the topography DXF. Try
Okay.
dragging that one in just in the same kind of way to see if that imports properly or if there's something broken with that file.
Yeah. Okay. So I have a message. Uh, it's in French, so it's said aucun importateur repéré pour l'extension de fichiers. As if it doesn't recognize .dxf. So I
That's
don't know.
odd.
So it's probably my installation that's I don't know
Right.
if Florent told us to not install some of the Python stuff. So maybe it's because of that. I don't know.
The Python libraries, at least in this version,
Yeah.
only adds support for OMF and
Okay.
LAS file imports. So be
Uh,
it shouldn't be changing anything with your GeoH5 file openings, and it shouldn't be changing anything with other imports like
okay.
um, what am I thinking? Like a DXF.
Yeah.
Maybe one other thing to think of before extracting that folder was it completely finished downloading?
Yeah.
It was? Okay.
Yeah. They are the same size too. So
Yeah, okay. Okay, let's see.
yeah.
That
Sorry for
file.
that.
Oh, these are the little finicky things that we have with the setup for these, right? Okay, let me see. It's a 20 megabyte file, the
Yeah.
entire archive, so I'm wondering if I can send it over email instead,
I think it's
or if I can drop it here
the
just to
program
download.
that's not able to read because it says
Hmm.
like it's not able to read .dxf, which is a topo for
Yeah, that's right. So
exercise 9.
so we're in general, we're definitely able to read the XFs, which makes me think that there
Yeah.
could be something wrong with the install if it's both that the workspace is failing to open properly and
I
that
could
you
try and
can't import the
reinstall it
DXF.
too.
Yeah,
Yeah.
give that a try.
Yeah.
I'm
I'll try
sorry, but
that
I'm
and
gonna have
you
to,
can continue.
yeah, I'll have to
Yeah.
keep going.
Okay.
Yeah, I'll have to keep going because just to try to fit everything in. Um, but
Yeah.
yeah, we'll try to catch you up when you do get it
Okay. Thank you.
back up and running. But maybe
Okay.
just I don't think, yeah, the zip is too big to share in the meeting chat, and I think it's like just a little bit too big to share over email.
Okay.
Um,
Okay, I'll try to. Okay, that works.
Sorry about that. That's
No worries.
that is one of those frustrating things that's tough to anticipate, right? Right up until we try doing
Yeah.
it.
Okay. I'll let you
Okay.
know
Yeah, yeah,
if it
yeah. Just
works later.
yeah.
Okay,
Shout
thank you.
out when you get it reinstalled. If you can open up that GeoH5, that's definitely pointing us in the right
Okay.
direction. And then
Okay,
we can check
awesome.
on importing the other files from there.
Yeah.
Okay. All right. So we did a little bit of navigating, at least, except for Alexi, I suppose. I'm sorry about that. Um, the next thing I wanted to talk about is some of the other panels that we're looking at. So we looked at that viewport panel right in the center of our screen. But there's a bunch of stuff surrounding it too. The first thing that I think we should point our attention to is that object tree. So this is the same area Alexi was indicating that he couldn't find any objects under his folders. The object tree panel will show us all the objects that are contained within our workspace, as well as the names of the data sets that are associated with those objects. The objects are organized in a tree type structure. You can expand and close the folders to see the objects inside them. And we can store objects in multiple levels of folders or groups. We call these container groups. You can create or change, you can create new ones by right-clicking and finding the Add Group selection in that context menu, and you can move objects around by clicking on them and dragging them into or out of container groups. Keep an eye on the icon that's shown right next to all the names in the object tree, as well as the label in the type column. That will tell us what group or group type, what object type, and what data type we're seeing in the object tree. So for the next thing to follow along with, let's take a look at this geochemistry container group and expand it by clicking on the little arrow tick next to it. Inside, we'll find one set of points called outcrop geochem, and we can expand that object, that points object, to see the properties that are properties or data sets that are associated with that points object. We can this object is not turned on for display right now, but we can do that by clicking on it and dragging it into our viewport. So let's do that together and drag the outcrop geochem into the viewport. And once you've done that, you should see that box fill in with a tick mark. And you should also see some points display in your viewport. All good. Then to color these points by one of the data sets that we have on them, we can pick that data set by clicking on the checkbox next to it. So let's first isolate it, turn everything else off in our viewport. We can isolate an object by right-clicking on it and picking View Only from the drop-down from the right-click context menu. That isolates that set of points for us. And then try viewing the properties on those points by clicking in the tick box. And take a look at what else changes on your screen. So we should see the colors of those points changing. Maybe the numbers of points that are being displayed are changing. And we're also seeing a change in the data colors panel in the lower right hand of your screen too. That look all right for everyone so far?
Yep.
Perfect. So we've colored these points by some values, but we might want to actually inspect a specific point and find what value is associated with that specific point. So recalling that the points that we're seeing are containers for data sets. In the case of a set of points, we can have one or more data sets associated with an XYZ coordinate location. So if we take a look at, say, copper, CuPPM, we can color those points there. And then if we want to inspect one of these points specifically, I'm going to see and anchor my rotation around this little cluster of pink points, and then click on one of them to select it. And then I'll take a look down just below the viewport at the data table area and see that one of the rows there has become highlighted as well. That row highlight in the data table will change depending on what you have selected in the viewport. The data table is dynamically linked to what is selected in the viewport, and vice versa. The selection that you make in the data table will update what you're seeing selected in the viewport as well. And that's how we can query what the actual CuPPM is associated with one of these points. There's a few other things we can see in this this panel where we find the data table. Right now we're looking at this nodes tab, but we also have an outcrop geochem, geochemistry, and workspace tab down here. These are our selection levels. So right now we are selecting and viewing at the node level, but we could also select this at the object level. So if I click on outcrop geochem, now I have the entire set of points in that object selected. The table also looks different. Here I'm seeing a summary of the entire object. Its type is points. Its number of nodes is 1535. It's painted with CuPPM right now, and I can see the object extents and range. Some other things we can do with the data table back at the nodes level is pin one of these columns to our mandatory XYZ fields by right-clicking on it and selecting pin. So if this is our main area of interest and we've got a large table like this geochem table, I can pick pin copper next to XYZ, and it shows up there with an italicized name. We can also sort by clicking on a column name. So I can click on CuPPM and sort descending by clicking on it twice. And I'll grab this scroll bar, scroll right back up to the top. And now by picking this value, I know I've got the highest value in that data set selected. So to follow along, basically follow those same instructions and see if you can select the 5 highest copper value points. You can multi-select in the data table by shift clicking. So I've got this top point selected. I'm holding down the shift key and I'll grab the top 5 like that. Are they in the same place or are they kind of scattered all over?
Scattered all over.
Bingo. It's not terribly useful if we're trying to narrow down a specific area to look at, if those points are scattered. Okay. Basically, what I wanted to demonstrate there is just our selection levels, nodes versus object. We're going to come back to that in the next few things, looking at different object types, but also selecting data from the table to query specific values versus in the viewport to query specific locations. So we can do that multi-select on the table, right, by shift clicking, but I can also do that in the viewport. Maybe I just want to take a closer look at this selection of points. I can do a shift selection box to pick those points. And they're also selected in the table. Now it's a bit harder to see these ones because they're all scattered by index level or by index order or by where the values are sorted, but the principle is the same. Just going back and forth between our 3D selection versus our tabular selection. All right, so we've started here by looking at a points object. It's probably the simplest object structure that we'll look at here. And it's one of 3 really basic node-based object types. So we've got a set of unassociated set of points. Each point is independent. It's not really connected or associated with any neighboring points. Once we do start to build an association from one node to another node, we'll start calling them curves instead of points. And like I briefly mentioned earlier, in another platform, you might find these called polylines or strings. We call them curves. Structurally, they're the same. What I've done is turned on roads, trails, and railways by clicking on the tick mark. And if I zoom in my camera and turn on show nodes and bring up the sides, the size of them, I can see that these curves are composed of several nodes that are just connected by a line segment. They're all ordered. One is connected to two, is connected to three, and so on and so forth. But if you break it down for spatial structuring, it's just a set of nodes connected by a line segment. Going a little bit more complicated, we've got surfaces, and surfaces are also composed of XYZ node coordinates. In this case, 3 of them connect to create a triangle. The triangles connect to create a surface. Does that rough breakdown make sense to everybody? I know we're starting out a little bit basic, especially if you've used a 3D platform before, just to get everybody up on the same playing field. The main thing where we want to go from here is to look at that object, the selection levels again for the different objects. So let's see what we can do first with points. I'll turn off that topography. We'll look back at our geochem points. And we're going to take a look at where we can control visual settings and data color plotting settings. So we'll start doing this with the points because they're the most simple. Outcrop points selected in the object tree. I'll direct your attention to this visual parameters panel. It should be in the upper right-hand side of your screen. This is where you can change basic visual styles of the entire object. So here is where you can say, I don't want to see these as spheres. I want to see them as points or maybe cubes or anything else that you can find in that dropdown. Here is where you can change sizes. You can scale points or objects by one of the data sets associated with them, and you can plot orientations on them. And we'll come back to some of these items later. So just for now, get your screen filtered again so you're just viewing that outcrop geochem. And if you need to isolate it again, find that view only isolate button. And what we'll do is try changing the node symbol back to point and changing the node size down to maybe 7. And uncheck the scale nodes by data button. So by changing those settings like that, point size 7, you should see something similar to what I have on my screen. Keeping in mind, I still have my points painted by CUPPM. And from there, if we want to scale, you can tick on scale. You can use the currently painted data, the CUPPM, or we can untick that and we can choose another property to scale these by. Maybe we want to view the color by CUPPM, but we want to scale by zinc or lead to try to identify associations in between higher copper values and higher zinc values. That's just a quick and dirty way to view or to get a visual representation of 2 of your data properties at the same time. Moving further down, in the data colors panel, rather than the visual styles, we'll control how colors are plotted and filtered on our objects. So here, we've already got this set up with a lower filter on 50 ppm, but we can reset that clip to view the entire extent of our data range by clicking the little scale button right to the right of the filter area. So that's right where my mouse button is. The tooltip there should say something like reset clip values. Clicking that will make a bunch of blue points appear on your screen. So we've removed that clip. We can also rescale or change the color table. You can change the color table by picking this drop-down menu and picking one of the alternate options here. And you can remap the color scale using the buttons on the right-hand side here. So here is where you might pick something like equal area mapping, although I'm not sure why you would do that with geochem. It tends to be the default color mapping that comes in. So often you'll have a color scale that looks like this. It's represented by the red line, and I'll come and talk about this histogram here in just a minute. But normally we'll want to remap that to a linear color scale and pick kind of an appropriate max value. So in trying to pick this max value, I'm actually going to look at the data colors panel here and check this histogram of my values. The histogram is all the values for your CU ppm or your currently painted or selected data. And it doesn't seem overly useful to try to break out a color scheme in this tail area above about 200 ppm. So I'll leave the minimum at 0.3 and I'll turn the maximum to maybe 400. That'll still give us a little bit of color differentiation between 200 and 400 ppm, but we'll flatten out this area where we have these higher outliers up from the 700 to 1000 ppm range. So you can test it by clicking apply, which will change the color mapping without closing the window, or you can click OK to apply it and close the window. So now I can see my higher range values are broken out a bit easier. I can see my pinks in here, and I've kind of muted the lower ranges quite a bit more. So just quickly to recap the difference between visual parameters and data colors. Visual parameters is where we control display styles for the entire object. Symbology, interesting display options like scaling by data. And the data colors is where we change color mappings to data and clipping values by for visibility. The next couple things we'll do is take a look at how the visual parameters and data colors panels look different for different objects, for our curves and for our surfaces. So for the time being here, we can turn off the geochem. And what we'll do is find that topography surface there we were working with. And you can bring this in by dragging it and dropping to recenter the camera on it and display it. If you've got something else on the screen, you want to isolate it, remember that view only button is under the right click menu on that topography surface. Okay, so what we're looking at now is the surface colored by elevation or Z value. Something else we can do with a topography surface is paint an image, a geo image on top of it. So we've also got under the geology container group, a 2D folder that contains a geology map. So that image might come in from something like a PNG or a GeoTIFF. It can be georeferenced, but it's flat. It doesn't have any real relief on it. What we might want to do instead of just plotting the image, if we want to use something like a scanned map for digitizing, is actually plot that image onto a triangulated topography surface. To do that, I'll pick the topography object in the object tree, check on Paint GeoImage or 2D Grid, and select that image. It may already be pre-selected from that drop-down. And now we've got that image shown on our topography surface. Doesn't really look like much because that topography is so flat. But something we could do there is play with this area on our viewport toolbar. This 1.0 is vertical exaggeration, and we can turn that off by clicking on the plus or minus buttons or just by entering a number right in there. So like I said, this area is so flat that we can't really see much. You can turn it up by turning these values way up to something like 4 or 5. And then you can actually start to see some relief around the lakes and around that green unit. Incidentally, because I haven't really talked about this area yet, the data set we're using here is sourced from the Flin Flon deposit in Manitoba. That's what we use for most of our demo and training data. Much of it is open source through open file report, but some of it particularly for the next couple sessions, I've created. So we're going to be looking specifically at this area, right around here, just south of the actual Flin Flon mine. The 777 deposit is up around this area. And kind of using some here. Talking about our object types and visual styles and data colors. So the next thing we want to check is going to be visual settings on curves. I guess just checking back to here. Don't really have any other interesting options. The is on top of the surface by dragging that one in. So yours may look a little bit different than mine now because I turned the node size way up just to show that these lines are composed of nodes. I'm going to turn them off and yeah, see this network of roads, trails, and railways all over the Flin Flon area. We can just like the nodes, we can turn segments on and off. We can change segment thickness. If you have a line ID data associated with your lines, you might see this for mag data, EM data. You can filter by line. We can display orientations here too, and we can show profiles. We're going to approach a couple of these again when we look at drill holes. I think those will be a bit more useful. But we do have some data associated with these curves. The one I want to look at is type. And notice when we click on type, our data colors panel actually looks different than that histogram we saw earlier. This color legend will show up when you have a categorical data type selected. So in our case here, type is a piece of reference data. That's our terminology for categorical data. There's a dictionary of values that each element can be associated with instead of just a number. This is where you might find unit data, rock types, codes, any other kind of category like that. In this case here, we're just looking at, you've got paved roads, trails, gravel roads, railways, and we can color objects by categorical data too. And we'll do that just by ticking on that type button and seeing each of the line segments colored according to which type it's associated with. So just like with the points, we can highlight nodes, view their type, scroll through the list of nodes to view the type highlighted, or select, turn off that surface, or select one of those nodes or line segments, or a selection, a multi-selection of them from the viewport or from the data table and see them dynamically linked as we select them. On selection levels, right now, again, we have that node tab selected. If I were to click over to segments, I can view individual segments. Typically, we're not associating data with line segments. It's way more common to see data associated with nodes, but you do have that option to view and sort by segment or associate your data by line segment as well. Looking over to the data colors panel, you may have noticed this line of I buttons. These are used for toggling on and off visualization of that type. So if I want to only view, say, paved roads, I can click on this one and find the isolate button over here. Single eye, click on that. All these eyes turn off, and all I'm viewing now are the paved roads. There's a view all button here as well. That views everything, or I can toggle these on and off individually. To change colors, To change colors of any of these, just click on the color, and that gives you a little color select menu. You can remap your colors. On that note, you can save these color settings and reload them. So what you might want to do if you're working with an imported geology map image, something like this one, is when you're trying to set up your lithology reference data, remap, pick a screen color. I'll probably do this a few times over the next few hours. Pick that color you want by screen picking it. And once you have all your units selected, save that color setting and then load it in again every time you bring in more data that you want to associate with those lithologies. Okay. That covers about everything I wanted to look at for those basic object types. Basics of the data colors table, categorical data and numeric data. The next thing I wanted to look at is drill holes, but just before we start looking at drill holes, any questions on any of those panels or the object types, structure in the data table, anything like that? This beginning bit is usually a bit slow once we get through the setup issues, but yeah, if there's anything about these concepts that seem confusing now, we'll cover those. Okay, perfect. Okay, drill holes. This is where things start to get a bit more interesting. Drill holes can't be structured in the same way as those node-based objects because essentially we have, and I'll take the Flin Flon DDH drill hole group, drag that into the viewport to turn it on. When we look at a drill hole, it's not structured in the same way. We don't have spatial associations with each interval. Instead, we have a collar location. The collar has a spatial coordinate. And then each line segment moving down hole has either a depth down hole or a from to depths to mark out an interval. And each of those tables associated with a collar and downhole piece of downhole data, they're organized relative to the collar at the top of the hole rather than a spatial XYZ. So we have to structure them a little bit differently. So we'll see these brought in. The easiest way to, I guess, conceptualize your different tables is looking at a collar table, a survey table, and then your interval tables after that. We don't see the collar table exposed in Geoscience Analyst, but we can look at an interval or point depth table. So the simple and first point depth table we might see is a static survey table. This takes a hole ID and then depths down hole with azimuths and dips for the hole trace. A simple interval table might be something like a geology table where you have from and to depths down the drill hole and logs, descriptions, lithological units associated with them. But like keeping in mind, none of these intervals are actually associated directly with an XYZ location. Right. Each of these tables are shared between all drill holes in a group. We can put many drill holes in a collar table and apply the same interval tables to many drill holes. And that makes it really easy to compare them to each other consistently. So let's stop talking about it and start coloring drill holes by something. The interval tables themselves are shown at the very top of this property list. And we can see interval table data group under the type column. Then we can see all the data sets associated with these drill holes. And there's a lot of geochem associated with these ones. So let's filter this long list and just look at the geology interval table by clicking on that geology box. That makes all the geochem disappear and gives us just a geology code, geology name. So then to color the drill holes by geology name, you can tick that box on and see the logs appear in our viewport. We'll also see that data colors panel update with our list of lithologies. So right now, referring back to the data table here, I've got the Flin Flon DDH tab selected. So this is at object group level. I'm looking at my drill hole group, and I've got 121 drill holes in the group. If I want to start querying a single drill hole and its interval tables, I'll need to select that drill hole. So I could take, say, 4Q15 here by clicking on it. And now I've got a set of tables down here. So these are handled in the same kind of in the same fashion as selection levels to tab through different tables. Each table is broken out by different intervals. And you can tab through each table to query that drill hole interval specifically. So in our geochem, we've got that long list of geochem and a few from to intervals. If I go over to geology, the intervals are different. I've got a 0 to 250, 250 to 325, and then I can see my intervals here. Just like those other objects, this table is dynamically linked to your viewport, and you can select by picking that row. I'm also seeing, in this case, the class, the reference class on that interval selected in the data colors. And I can also pick an interval on a drill hole in the viewport by clicking on it, which will highlight that drill hole and grab that interval in the data table. So that's all dynamically linked. That's basically our method of querying these drill holes. If you've used another platform like Leapfrog before, that's handled in a little box pop-up in the lower left. For us here, we're looking at it in that data table. That's where we're looking at all our data that's associated with any object viewed in 3D. All right, let's play with some drill hole visual styles. Let's scroll down the list here and find hole FFS 039. I've already got it in the viewport because it's been dragged in. I can recenter on it by dragging it in again, and then we'll isolate it by right clicking and picking view only. So now we can see just that one drill hole. That's turned off all the other ones. We have a few more options here in our visual parameters. So we can change the path color, turn on and off the collar, turn the path on and off. We're not seeing a difference here because we've got the log displayed on the screen there. Name, change the path thickness, show some depth intervals on this drill hole. And change the log style between a line appearance like this or a cylinder appearance like that. So just like the scaling on those points that we looked at earlier, we can scale cylinder type logs. The line type logs won't scale because it's just a 2D line. But if we have a cylinder log shown with a numeric piece of data attached to it, then we can scale that. So let's paint by something numeric. We'll tab over to the geochem table, and you should be able to find that CU copper property. You can find this one either somewhere up here in the object tree by searching through that geochem table, or you can find it in the data table and click the little paint bucket beside it. That's your other option to recolor objects by different data sets. Click that paint bucket. That changes the log appearance. Now we've got a bunch of kind of discontinuous disks running up and down that drill hole, representing your copper assays. So we can scale those two. I'll tick that on, and we can pick any one of these elements. We can scale it by copper or try scaling it by zinc. Again, just like we did with the points. One other thing we can do here is show a piece of data by profile. So if we tick on profiles, we're already set up with magnetic susceptibility reading shown as a profile type log. And you can change and play with the parameters there. You can try scaling in the camera or just play with the scale and crossover in the visual parameters tab. Any questions on drill holes? Does that all seem relatively straightforward? Perfect. Two other object types to talk about before we move on to some other more interesting stuff. Grids and block models. So far we've looked at those node-based objects, just either unassociated nodes or collections of nodes linked by some element. And we've looked at the drill holes, which are essentially one spatial coordinate and then some table associated with a downhole length from that spatial collar coordinate. Grids, 2D grids, 3D grids are a little bit different here too. In this case, we're trying to describe a volume of space instead of just a spatial point coordinate somewhere in space. So while you can reduce a grid cell to a single point on its center, it's more useful to try to display data on a continuum from one region to another. And I just picked under model and this Flin-Flon model. This is useful because we can use it to transform discrete data, like those point data, into a complete 3D volumetric representation that can be visualized, queried, and analyzed. But it's important to remember that when working with grids, we are working with models. Unless we have collected a primary piece of information at every grid cell, we are estimating what that element that is associated with that grid cell. So from there, we can start talking about data density, the assumptions we're making in modeling the data, and what uncertainty is inherent in making those assumptions. So just to get a feel of how we can work with models in our viewport here, we've got this Flin-Flon model, and we've got 3 pieces of data on the Flin-Flon model that we can view it by. So drag that model into your viewport or turn it on, isolate it. So we're looking at something kind of green like this, and then try painting it by the geology to see a 3D representation of a geological model rather than just, seeing the drill holes, seeing some surface samples. We've got a few more interesting options in visual styles for block models to play with. And we'll scroll down here through to, I want to look at ISO values. So with your Flin-Flon geology, Flin-Flon model selected, pick ISO values. And in data, pick Flin-Flon geology from the drop-down menu. And then in classes, let's pick the 6 Millrock member. That's the yellow unit to turn on ISO values for that unit. So that's showing us that while we're only visualizing, by default in these 3 section planes, there is actually data associated with everything contained within the green extents box. So we'll leave that ISO value on, and we can actually scroll up and turn those sections off to declutter our viewport a little bit. And to make this a bit more interesting, let's, in your object tree, find MagSus and click on that one. So now what we're looking at are those ISO values for that one litho unit, but they're colored by a numeric property by our MagSus. Next, let's try picking a few of these blocks. So that dynamic linking is all still here. I know I've been kind of hitting that again and again, but just to make sure everybody feels really comfortable about querying blocks and items, blocks and objects in the viewport, I'm going to keep coming back to this. What we'll do is I've picked a block here. I want to know what the MagSus value for this block is. I'm going to take MagSus, pin it next to mandatory fields so I can see it. And now I can start picking these different blocks, see what actually is this higher color coded area around 0.035, and what are these background levels, and they are all right around 0. And something else we can do here too is sort by magsus. Since there's a cell count, there's a higher cell count on here. It's going to take a second to sort. And then we can select all the higher values on in that block model, all the higher magsus values in that block model, and see them selected in our viewport as well. So just while we're waiting to sort, do we have any questions on anything? Anything you feel like we should be able to do in here that you haven't seen me try yet? Feeling good? Okay, taking a while to sort. All right, it's been about an hour. So on that note, if anybody needs a 5-minute break while we're waiting for this to sort, go ahead and take your break.
Can you re-explain how do you? I don't have a volume like you. Like it's more like section. So can you show me a second time, please?
Yeah, for sure. My
Thanks.
screen is a little locked up here while waiting for that to
Okay.
sort, but you'll find that look in your visual parameters panel over on this side and look down until you find ISO values. I'm afraid I don't have my labels are all in English, so it might look a bit different on your end.
It's in English too, so.
Okay.
Okay, I find it.
Yeah. Yeah, so the ISO values are really useful because we can display those ISO values, but color by a separate type of data. So you can use that. We'll come back to some of this later once we kind of get past, where to look for the different things. Try to over and over and over a few times to start using things like that. Setting up. There it is. Finally, that took forever. Shouldn't beware of sorting on very large objects. That's a takeaway from that one. Viewing those ISO values and coloring them by a different data set can be really useful in setting up where you want to see two properties intersect. So maybe I'm interested in both this lithology and the magsus model, but only the magsus model on these ISO values. Now I get a really immediate representation of where I have higher magsus values restricted to only within this lithological domain. A couple of these concepts are going to kind of keep coming back to a few times. But yeah, ultimately what we want to do with the tools is intersect different domains, properties in order to build our understanding of how they are associated or not associated. Okay, I told everyone to take a 5-minute break, so I'm going to give another couple minutes until we start coming back. I'll leave this the way it is. Because I just want to take a look here at some, this is pretty much towards the end of this section on just some basic visualization stuff, but we still got to talk about cutting slices and walking through slices. Okay, 2 more minutes and then we'll resume. I'll be right back. We're all feeling all right, then we can carry on with a couple of visualizations and then move on to importing some data. Okay, so when we left off a couple minutes ago, I had sorted those magsus values. We had turned on ISO values for the Millrock unit and colored it by magsus. So just scrolling up here, maybe I just want to select some of these highest magsus units. I can keep walking up and see those higher values being picked. Even though these ones aren't visible, because I don't have ISO values turned on for this region, I can still see the yellow selection outline there. Okay, but what we'll want to do is explore how we can view our drill holes against a slice of our model. Really the component or the concept I'm trying to go for here is like we've mentioned, basically any gridded representation of data is modeled data. And a key component in assessing how accurate that modeled data is comparing it back to the primary data. Drill holes are primary data, surface observations are primary data. So while I've got this nice looking model, how do the mag-sus readings compare to measured downhole mag-sus readings? To get a visual representation of that, we'll bring in our drill holes again. Actually, just specifically, we can bring in that FFS 039. I just snap my view to it. We'll turn off those ISO values for now. If you don't see the same options in your visual parameters, it may just be because you don't have the same object selected. So double check that you've got the Flin-Flon model selected when trying to turn off the ISO values. Uncheck that one. Now it's gone because I've got those sections turned off too. So Gillian, if you wanted to turn off those UV and Z sections, you can deselect them here. I often do that, especially if just viewing some ISO values, or if just trying to set up my own drill hole section like we're about to do in the next little step here. So for our drill hole, we can see it here. We've still got that mag-sus profile on it, but I think it's a bit more valuable here to compare by plotting that right on the drill hole rather than as a profile. So we can change that again. I'll pick the drill hole just by clicking on it. I've got it selected in my object tree, and my visual parameters panel's been updated too. I'm looking at visual parameters for the drill hole. So here, I'll scroll down, turn that profile off. And in my data table, I'll look over to the geophysics table and color this one by mag-sus. These are point depth readings, and they're very tightly spaced. So if we zoom way in on that drill hole, we can see just how tightly spaced those point depth readings are. So it's actually a bit more useful on point depth tables like this to scale them by that data and plot it more like a lathe. So we'll go scale by mag-sus. And now we can get a better idea of where the higher and lower values are. Is everybody able to plot their cylinder logs like that? Yeah. Okay, now that we've got something we can see down hole, I'll go up here to this viewing orientation toolbar area. So just a quick way to reorientate yourself. Look west, look north, east, south, and in the middle, view from top. So to set up a section along this drill hole, let's view from top and look in plan view. And to set up our viewing plane like a section, X is the hotkey for cutting slices and sections. So just look somewhere towards the bottom of that hole. One more thing before I forget. Look into this area here. There are two viewing styles or two perspective styles. The default here when you open this is we're looking in perspective view where everything we're seeing converges into a single point at distance. It's a bit more realistic to the way we see the real world, but when we're working in 3D with a model or with data that we want to line up, it's way more useful to view things in parallel view, where everything is projected in a rectilinear flat fashion. So before cutting a slice, let's switch to parallel view. We'll see that drill hole kind of change in shape when you switch that view. But now it'll be more realistic to cut a section along it by pressing and holding X, and clicking and dragging a line from the toe of the hole around here where your depth tick is 1121 up to the collar of the hole where the depth tick is 0. So once you're satisfied with that blue line, that's going to be your slicer or your section plane. Let go of the mouse button and the X, and you can see that slicer plane show up in yellow. The default way these slicers behave is that what we've done is actually cut off the back of the image. So now if I were to display all drill holes, I can do that quickly by right-clicking on the drill hole group and going view all. We only have the drill holes to the south of that slicer plane displayed. That's one way to do it. We can set up multiple sets of these slicers to kind of isolate certain areas. But for setting up just a nice section to look at, what we'll want to do is change this to a thickness type slice where we have one plane with clippings on either side to view that drill hole. So what I'll do is just take that drill hole we're interested in and isolate it again by viewing only. Make sure that slicer is turned on. These slicers are treated as objects and they do have visual parameters just like any other object. Turn on the slicer, go quick slicer, and down at the bottom of the visual parameters panel there, find type, slice, and turn slice on. And that gives us a 50-meter clipping on either side of that slicer plane. Does that make sense to everybody when I talk about clipping distances, remove front, remove back, that kind of thing? Basically, we just want to take that one little slice and view that just like those sections we were seeing on the block model when we first turned it on. So now I've got that slice set and we want to look at that slicer plane. There's a button to do that on the viewport. It's right above that perspective view button. And the tool tip there should say look orthogonal to slicer, and that will flip your view to look directly at the slicer. Just like that. Now we've got a drill hole section. And you can click that button again to change the angle you're looking at it from. So let's try to set it up here, just so we're looking at it coming down from the collar in the upper right to the lower left. Okay. What I said at the beginning of all this is we want to compare this primary data to modeled data. So to do that, we'll need to find our model again, flin-flon model, take that, drag it into the viewport or make sure it's turned on somewhere. You won't be able to see it at all because we turned off all our sections and we turned off our ISO values. But we can set up a section on the model that snaps to our slicer plane using the arbitrary section. So just below your U, V, and Z sections, turn on the arbitrary section. And in the align with slicer box, pick the quick slicer. That's the one we just made. And now we've got that plane on the model plotted against the drill hole. And you can still rotate around to see that it's relatively close. Drill holes aren't straight. They always deviate. So it won't be nicely on plan, but close enough for at least to make an assessment of how closely that model matches the drill hole. However, on that note, you may notice that the color scales are not the same between the modeled mag-sus and the drill hole mag-sus. We do not need to remap one of the colors. We just need to take that same color table that's associated with one of them and apply that to the other piece of data. So let's say we want to use the same color legend that we see on the flin-flon modeled mag-sus. What we'll do is open up our object tree so that we can see types. So you may have noticed if you've kept this object tree open fairly wide that types on data look a bit different than types on objects. The actual data type like float, reference, integer is just in brackets. That's because each of these properties, they get assigned their own unique data type, and that's associated with a color scale. So what we'll want to do here is take this model merged float data and assign that, scroll all the way up to the top of the drill holes, assign that to this mag-sus data that we have on the drill hole. Does that make sense to everybody, or am I kind of going off somewhere a bit weird? Basically, it's the data type. The data type is associated with the color mapping and filtering settings. And we want to use the same color mapping, especially when comparing primary and model data, so that we're comparing the same thing to the same thing. It becomes meaningless if we use different color scales for our primary data versus our model data. So the way to do that is by taking this magsus, right-clicking on it, and reassigning the data type. So go ahead and find that reassigned data type on your magsus on the drill holes. That opens up this reassigned data type window. And recall we wanted to match these colors on the drill hole to the colors on the model section. So we'll scroll down and just double check what the name of that magsus data type is on the model. And it's called model merged. And we can find that by searching it in this window here. Try typing in model, you should see that one show up. Click on that and click OK, and see your drill hole colors change when you click OK. That's something to always keep in mind. Depending on the tool we use, when we run interpolations, which we'll do soon, data type is preserved from the source data to the transferred or interpolated data. But depending on how we've imported and set up our objects, it's something we always want to keep an eye on, that we're comparing the correct colors on primary and estimated data. So what we can see here right away is that some of these drill hole values don't line up perfectly with the model. And that's okay. Essentially, and we'll come back and take a look at this model later, actually. Downhole readings like this are not used to inform, downhole readings like your magsus readings are not typically used to inform a magnetic inversion model. Instead, there's a different equipment and instrumentation used for picking up those readings. So when the data was collected to run this 3D magnetic inversion, these downhole magsus readings didn't really exist. That being said, they can be used to check the model and update the model. Any questions on that?
I don't find the model merged flow data on the reassigned data type window.
Okay, can
Like
you?
When I try to filter by name, it just doesn't appear.
Did you type? Was it a capital M? It's those are
Oh,
case
okay, it's a
sensitive.
capital M. Okay.
Yeah, I should have mentioned that they are case sensitive. That search box. So just quickly before we move on,
Okay.
one other fun thing we can do. Oh, where's my view? Here we go. With this is move that slicer plane and kind of walk through a 3D volume to see how one section compares to the next. That can be useful for a couple things, for inspecting a model, walking through a drill hole pattern, digitizing contact surfaces on your drill hole pattern, and just helping build your own 3D understanding of the objects and data that you're viewing. And I can do that by, using these arrow buttons to move back and forth, and we'll see this section update. Let's say, you know what we'll do? Rather than painting this by that magnetics model, let's paint it by geology. We'll do that just by clicking on Flin-Flon Geology in the object tree. And then what we could do here is actually, if we want to compare the geology model to our log geology, is turn on geology on our drill holes and view all drill holes. And there we might just want to normalize all our log visualization types, view these as lines or cylinders, change the size so that they're all visible. What you may have noticed is that there's different visual styles on my drill hole here than my drill hole here. That's because those visual parameter settings will be different for each drill hole if you start picking drill holes and editing them. So if you want to keep them all normalized, play with the visual settings with the entire group selected. Right, but what we wanted to look at here was walking through these sections. So with that slicer selected, under Tools, Slicer, Quick Slicer, We can move back and forth along the plane normal with the arrow keys, or with the slicer selected, I can press and hold the X button and scroll my mouse wheel to walk through this very quickly. But it's really easy to lose your sense of orientation when you're walking back and forth through sections this quickly. So something we can do to make that a bit easier is open another panel. We can open up to 8 of these viewport panels, set them up in different orientations, section, long section, plan view. So what we might want to do here to help keep ourselves orientated is open a map viewport. Didn't mention that we can drag these panels all over the place either. You can take any of these panels, drag them, move them, close them by picking on the bar and dragging them like that. So what I'll do is tile this map view I opened with my visual parameters panel like that. So I've got a little key map view here. Now it's not super useful here because I still got nothing over on nothing plotted, horizontally. That's okay. Since I've got this viewport 2 map view selected, I can turn on different sets of objects here. So I could go into my topography folder, drag this into the map viewport, drop that in there, and turn off the slicer on it. So the slicers are all objects, can all be assigned specifically to different objects. You can slice some objects and not others. That's what this column means. This is meant to be a little X-Acto knife, and it shows that I've got my sort of beige colored quick slicer applied to all of these objects. If I right click on topography and go to the slicer menu, I can turn it off. Since I don't have the topography turned on in my primary viewport, I can't see it. And since it's not sliced, I can see the whole thing in map view. Then maybe I'll just change the color of this slicer. That would be in visual parameters, slicer, change that to black. Now I can see a black outline where my plane I'm looking at is. And then as I move that moves along in the image. Maybe I want to follow this contact between the yellow mill rock member and the green hit information. I can turn on this link cursor button and leave that there as I roll through the sections, and it updates once I take my finger off the mouse wheel to see whether this modeled contact matches the one on the map. Okay, enough about slicers for now. Any questions on what fun things we can do with those? Feeling good about them? They make sense to everybody. It makes sense why you would want to look at something on a 2D plane as well as in 3D space. Maybe switch back and forth quickly, rotate around it. Okay.